Wow, what a discovery! Beneath us, inside the Earth, is a world of its own, with mountains that are sometimes 5 times higher than Mount Everest. In this video, we take a fascinating look at this underground world and explain how it was discovered in the first place. So be sure to stay tuned until the end, and if you like it, I'm galactically happy about a thumbs up and a comment, because that's how we get the YouTube algorithm to show this video to even more people. Thank you guys and welcome. Have you ever read Journey to the Center of the Earth by Jules Verne? Let me know in the comments. This incredible discovery reminds me a lot of Jules Verne's famous adventure book. At the boundary between the Earth's core and mantle, there is an as yet undiscovered layer of ancient ocean floor that is littered with gigantic elevations. But first things first. The story begins in the Antarctic. Near the South Pole, a team of researchers from the University of Alabama used a new analytical method to record seismic waves that traveled through the Earth's interior from earthquakes on the other side of the planet and were then finally picked up by the measuring station in Antarctica. Well, the researchers were quite astonished when they analyzed the results. The researcher involved, Dr. Edward Garnero, said, "In analyzing thousands of seismic records from Antarctica, our high-resolution imaging method found thin, anomalous zones of material in the CMB everywhere we probed." For once, CMB does not stand for cosmic microwave background, as is often the case here on the channel, but for core mantle boundary, i.e. the boundary between the Earth's core and mantle. It was precisely in this mysterious intermediate zone in the Earth's interior that the researchers suddenly discovered very strange anomalies. What could this be? The researchers immediately had an idea. Logical, because the Earth's core is also there. Core competence. It is probably submerged ocean floor that has gradually covered the entire area between the core and the mantle. Huge deep-sea trenches, such as the Mariana Trench, form where plates meet under the ocean. When these plates meet, this is called subduction. And over the course of very long periods of Earth's history, one plate pushes under the other. In the Mariana Trench, for example, gigantic quantities of water are pulled into the Earth's interior in this way, which then go through a still relatively unknown underground cycle and are spewed out again from deep-sea volcanoes in another part of the ocean. Sounds like a wild ride on the water slide at the outdoor pool, but I strongly advise against deliberately getting subducted in the Mariana Trench. This whole process could also have played an essential role in the origin of life, as the first organisms are thought to have originated in just such deep-sea volcanoes. If only the first bacteria had known back then what they would cause millions of years later. Be that as it may, it now looks as if these sunken seafloors have formed their own layer in the Earth's interior over the course of time. In this illustration, you can see how you can imagine this newly discovered layer. But scientists always need a very fancy and complicated name for things, so they call this anomaly ULVZ, which stands for ultra-low velocity zone, i.e. areas of the core mantle boundary where seismic waves suddenly only travel extremely slowly. Until now, it was assumed that these ULVZs only occur in small patches. However, these new research results indicate that the entire core mantle boundary is covered by an ultra-low velocity zone due to the subsidence of the seafloor. The lead author of the study, Dr. Samantha Hansen, says, "Seismic surveys like ours provide the highest resolution view of our planet's internal structure, and we're finding that this structure is far more complicated than previously thought." How exactly can we imagine this ULVZ region? Very irregular, because as the data show, its thickness varies between 1 and 10 kilometers. These anomalies therefore sit on the Earth's core like mountain ranges. And these immense differences in height mean that we see mountains in the Earth's core that are up to 5 times higher than Mount Everest in some places, as I have visualized for you here. Crazy, isn't it? There are already rumors that the Yeti is on its way somewhere.
Прям на нас. Господи! Ой ты, батюшки мои, босса! Фу, пронесло.
So we found anomalies between the Earth's core and mantle, which have formed from subsided ocean floor and form gigantic mountain ranges in the interior of the planet. Some of you will now say,
"So what, dude? Why is this important to me? I'm going back to watching TikTok."
it's important to understand the overall geophysical system of our planet. These Jules Verne-esque mountains inside the Earth could play an important role in how heat escapes from the core. And that is, after all, the part of the planet that drives the magnetic field. The Earth's magnetic field, in turn, is our protector against the dangerous and high-energy particle radiation from the Sun. Among other things, we could be in danger in the future if a pole shift were to occur, i.e. if the magnetic poles were to reverse and the Earth's magnetic field were to go completely haywire for an extended period of time. The better we understand how the Earth's core works, the more certainty we will have about such magnetic apocalypse scenarios. The question is, of course, how we could find out more about this now. The seismic data are of course only ever indirect observations, and it will be very difficult to just dig there. But how would it be if we simply stood next to a volcano and waited for material to be spewed out of the ultra-low velocity zones?
Ah, great joke, Tim. We all laughed.
No joke, material from the old ocean floors can be entrained in mantle plumes or hotspots, which are then brought back to the surface by volcanic eruptions. Sometimes science is simple. So by analyzing the material from certain volcanic eruptions, we could actually get information about this mysterious world beneath our feet. I think Dr. Samantha Hansen put it very nicely. There is still so much unknown about the world beneath our feet, and even small-scale structures, like the ULVZs we have recorded, may play an important role in the functioning of our planet. I would be interested to know which of these places you would most like to explore completely if you could. The Earth's interior, the ocean floor, or an alien exoplanet? Write your answers in the comments so that we can make it a representative vote. I'm very curious to know which of these places most of you would most like to explore. Quick note that I'm just shy of 15,000 subscribers, so if you're watching this video and haven't subscribed to the channel yet, or know any space-loving friends and family, I'd be galactically happy if you'd help me fill up to 15,000 so that my channel becomes an UHSZ, an ultra-high subscription zone. Thanks, guys! There's not only a lot going on in the Earth's core, but also in our Milky Way. We are no longer alone, because our neighboring galaxy Andromeda has begun to merge with the Milky Way. You can find out what this means for the Milky Way and whether we will soon see intergalactic neighbors flying past us in the video below, where I have explained everything about it. And if you want to support my work, you can buy the shirts from the videos, plush planets, and real meteorites in my space store. Every purchase helps me to keep the channel going. Otherwise, I'd say see you in the next video. Take care, guys.